Well, good evening, everybody. We have a lot I want to talk about in relation to Hurricane Florence. Sitting out there in the Atlantic, a lot of you, watch different weather sites and read and follow different models. And there's so much going on right now with this system that we want to give you a very in-depth explanation of what is happening. Here, of course, is Africa. Storms that come this time of year off the coast of Africa are sometimes some of our biggest storms. The Cape Verde Islands, actually they've renamed them, but it still shows up on maps as Cape Verde. They are now the Cabo Verde Islands. And you'll notice there's still two waves down here, bottom side of your screen, bottom right-hand side. Those are two new waves that have come off. Meanwhile, Florence started out as one of those waves and is now in the central Atlantic. So let's zoom in on this storm a little bit. And it is a very, very powerful storm. Right now, a Category 4 storm. It was supposed to be a tropical storm today, or maybe at most a Category 1 hurricane. But despite its very significant power, it's a very small storm. What we call the central dense overcast, that's the main core of the storm, is 122 miles in diameter. Now, some of these upper clouds, they are spread out farther than that, but the main core of the storm is only 100 to 150 miles in diameter. Again, right now, though, a Category 4 storm. One of the things with systems like this is they need warm water. Well, the water is relatively cool in front of it, and they need a lot of humidity. And the air in general around the storm where it was tracking from yesterday was supposed to be very dry, only 20% humidity. So all of the ingredients look like the storm would actually weaken, if anything, and then maybe in a couple days start to strengthen. The same thing goes for the forecast out there for the next few days. It is supposed to run into some warmer water now, but increasing wind shear. So we think as it gets into the increasing wind shear, that should tend to pull the storm apart a little bit and weaken it back to a Category 2. But again, this storm has been so far off of what was supposed to happen with it that you have to take everything with a major caveat, not a grain of salt, take it with a ton of salt, because this thing has just done totally the opposite. Meanwhile, here are the various computer models. The UK Met, and then you've got the Canadian. These are all separate computer models by different countries, by different entities within the US, for example, like the H-WRF and the SHIPS model. The H-mod's another American model. So those are where the various computers say it's going. This, however, the famous Euro, everybody talks about the Euro or the ECMWF, and it has been the strongest storm tracker over the last 5 years, the most accurate, I should say. So they run it one time, and that's what you typically see. If you go to a website or a weather site, they're going to show you where the Euro is predicting the storm to go. If that's all you saw, you would see this storm right in there, getting just east of Norfolk and spinning back around. More on how it's been flip-flopping coming up in a minute, but spinning back around down to the south, doing sort of a U-turn offshore. That would be pretty bad for Hampton Roads. It wouldn't be a worst-case scenario because the storm is offshore, but it would be very bad. Then what they do is they say, okay, well, let's run it again, see if it comes up with the same answer. And they get this line, and then let's run it again, see what answer we get this time, and it's this one. When you get a storm that has so many different variables steering it and the pattern is so diffuse out ahead of it and that anything could really happen depending on approaching cold fronts, etc., that's when you get a huge spread in the models. So what they do then is they take all of those, I think it's 51 or something runs, and they average them together. The average, we can't plot that on this particular graphic, but the average of all of these actually takes it to about Bermuda and then offshore. So again, even much farther offshore than the just simple one run of the Euro took it. This is what the GFS, or the Global Forecast System model, is calling for. Run it one time, and it comes out with this path. And then it actually extends beyond this and curves it offshore. Very similar to what we were just looking at, remember, with the Euro, keeping it offshore but not by a ton, and then taking it out to sea. You average all of the 30-some runs together of the American model, And this is where the blue line shows, passing east of Bermuda and then curving out to sea. Some storms, the single model runs best. Some, in many cases, though, the average turns out to be the best predictor of where a storm is going. So with this one, we'll have to wait and see. Both those, what we call ensembles, are showing a huge difference over the single run or the operational run. This is something else we like to look at. We said take every storm in recorded meteorological history that has been within 200 miles of where this storm is and show us where they have all gone. And they are, as you can see, all over the place. The important thing to notice, however, is that one's gone into Florida near Cuba, or Cuba, excuse me, and then the Gulf over to near Houston. Another one came up here and hit near Savannah, Georgia. One came up over the eastern areas of North Carolina. A couple came offshore. One did a loop and then headed up toward Quebec and Maine. But the vast majority of these storms, out of, I don't know, maybe several dozen, 4 or 5 dozen of these storms that have gotten this far north in terms of latitude, only one has hit Hampton Roads. If we can come back to me. This one right in here. So you say, what storm was that? That was Isabel. Isabel, back not that many years ago, caused tremendous, just massive amounts of damage in Hampton Roads and up and down through the eastern seaboard here, especially in eastern Virginia and eastern North Carolina. So that would be really, really bad. There are, however, some differences with Isabel and with this storm. Oops, that's actually not what I wanted to show. I wanted to, well, we'll just talk about it. So we'll put these back on here. With Isabel, 7 days out, there was very little spread in terms of the computer models. We'll actually go back here to one more backwards, and we'll show you. When we ran the Euro, for example, with the storm Isabel that came through, it didn't have a huge spread like this. They were all pretty concentrated, even a week out. We knew it was somewhere between like North Carolina and Delaware. And then as it got closer, same thing, because the upper air pattern was not changing very much. We didn't have a cold front coming in, trying to pick it up, and then maybe dropping it, and depending on how quickly it drops it, you know, let you know what sort of area it's going to. So a lot of differences with this storm versus Isabel. If you just look at history, you don't look and say, well, Isabel did it, this one will too. That just shows you the possibility is there, but based on history, that's not the one I wanted. I wanted to go one more ahead of here. So based on history, there's a 5% chance that this storm would hit us versus going somewhere else. Now, in this case, we're not going to say the odds are that low, certainly, because the upper level pattern is a little bit different. The fact that some of those models are bringing it a little bit closer right now, this far in advance, the most likely would probably be somewhere here, a little offshore to maybe a few hundred miles offshore. But that's something we're going to have to watch over the next week, because that is not for over a week from now that would happen. So an awful lot can change. The cold fronts that are going to eventually steer this storm, they're not even in the U.S. yet. They're not even over Alaska. They're still way up there in Siberia. So they have to come over the top and come down. And obviously, we don't have a great handle on what storms over Siberia are doing, for example. So that's what we'll be looking at over the next week. We will have a lot more. Hope you found this informative. Have a great evening. And it's a good time to remind you, you should plan for the worst, but hope for the best. This is the bulk of hurricane season, the peak of it starting to come now. So have your plan in place just in case we need it in a week.